Hello and welcome to this section of the Matlab tutor. Here we're going to cover a very important concept that you really need to understand in Matlab. It's one of those core things that if you don't understand it or get it, then you're going to scratch your head with some error messages for no reason. It's just one of the quirks of the program that you have to know. And it involves multiplying vectors together. So we've already talked about the dot product and the cross product, and those are typically the mathematical functions that you are applying to vectors most of the time when you're trying to multiply it. When you're doing the dot product, you want to calculate the dot product in physics or in mechanics or something like that. And also we've learned in math and science when the cross product might be useful. So the dot product, don't forget, multiplies two vectors and it returns a single number, a single solitary number. And the cross product returns a vector, right? And you should know what those terms mean from your math and science classes. But there is occasion, now that you understand what a vector is in terms of MATLAB, see in MATLAB a vector is a list of numbers. You can certainly calculate dot and cross product with it, that's cool, but it's more importantly a list of numbers. So let's do a little experiment. What if I were racing some cars? Maybe I had 5 cars I was going to race. And whenever I get started, each car is going to have a speed that I can measure. Right? I can measure it with a radar gun, and they're all going to be going different speeds. And I have somebody that has a stopwatch and is basically letting each car travel a different amount of time. So car number 1 we might let it go for 2 seconds. Car number 2 might go for 4 seconds. Car number 3 might go for 6 seconds or whatever. So each car has a different speed, and each car is allowed to travel for a different time. So maybe it's not so much a race as it is just an experiment. And we would like to calculate how far does each of these cars go. So you might do something like car 1 speed is equal to 2.4 meters per second, right? And you might say car 1 time is, let's say, 3 seconds. So if you know the speed and you know the time of anything, then car 1 distance traveled, right? Distance is speed times time, right? So we might say car 1 speed times car 1 time, right? So the car 1 distance is 7.2 meters. If it's going 2.4 meters per second and it's allowed to travel for 3 seconds, then when you multiply those things, you're going to get 7.2 meters. So that makes sense for one car. That makes total sense. But what if we're just doing a lot of experiments? I don't know. Maybe we're just for some reason wanting to see the different speeds of these cars and just see how far they travel. We're just doing a simple little experiment, right? So let's say we have 5 cars. So each car, let's say, has a slightly different engine, and so it's going to each car is going to travel with a different speed, slightly different speed. So we can have a car 2 speed, a car 3 speed, car 4 speed. And let's say for whatever reason in our experiment, we let the cars go for different amounts of time. So the car 2 time might be 2 seconds, car 3 time might be 4 seconds, and so on. So we could do these calculations over and over again, defining a car 2 speed and a car 2 time and a car 3 speed and a car 3 time and so on. And we could calculate the distance of all these cars and we could store them in all these different variables. And that would totally work fine. But that's really not using the power of MATLAB, because the nice thing about MATLAB is you can store everything in these things we're now calling vectors. And so you can store them as lists of numbers, and it's much more compact than defining all these vectors. So let me show you what I'm talking about. Let me clear the screen and let me clear all these variables out because let me clear all. Because they're not really relevant to the discussion going forward. So let's, instead of doing car 1 speed, car 2 speed, let's just make a vector called car speed, right? And by the way, when I define my vectors, if I have 2 words in a vector, I like to capitalize the first letter of the words. It just helps you read it a little bit better. So notice I don't have car 1 speed, I just have car speed. So I'm going to open up a vector here, and I'm going to say, okay, first car was 2.4 meters per second, next one was 1.3, next one was 1.5, next one was 2.9, next one was 2.7. So you see now I have 5 speeds, 1, 2, 3, 4, 5. I have 5 speeds for the 5 different cars in there, and I've basically assigned it to a vector. So the first number corresponds to car 1, then car 2, then car 3, 4, and 5. So then I can define another vector called car time. And this is the time I'm allowing each car to travel. So the first car I might allow to travel 2 seconds. The next car, maybe I'll let it travel 3 seconds. And then the next car, 4 seconds. The next car I let go for 3 seconds. And the final car, let's just do 1 second for that one. So I close the bracket off, car time. So I hit enter. Now I've assigned this data to car time. So basically you've done an experiment in the lab. I know it's a silly experiment, all right? I know that, but you have to use your imagination here. We do an experiment. We collect some data. That's what you're usually doing with Matlab is you're grabbing information and you're massaging it and learning from it in the Matlab environment. So we have 5 cars. We have 5 speeds that we measure, so I record them. Corresponding to those guys, I have these guys going down a racetrack at different times, and I would like to calculate how far down the racetrack they should go if I've measured their speed and I've measured the time traveled. Well, we did it with individual variables before, but now we have all of this data stored in these convenient variables. So I can actually create a vector called car distance, right? And I can set it equal to car speed times car time. That makes sense, right? So I could take car speed, which is this guy, and I can multiply it by time. So speed times time should give me distance, and I should get 5 different values for distance. So let me go ahead and hit enter. And it does not work. This is why when you're using MATLAB, sometimes things that make sense to you, when you start getting a little dangerous and you can get out there and start really doing some stuff, it seems like it should work, but it doesn't work. And the reason it doesn't work is actually something you already know. It's because these are vectors. They're treated as vectors. When you try to multiply them like that, it's going to try to multiply them as vectors. Now don't forget, when I say vector, these things are really matrices. Car speed is a matrix with 1 row. Car time is a matrix with 1 row. So what we're trying to do here is multiply 2 matrices together that each have 1 horizontal row. And if you know the rules of matrix multiplication, you can't do that. When you multiply matrices, you have to multiply across and then down. And not only that, the way matrix multiplication is set up is you're multiplying element by element and you're adding up the sum. So if we actually could multiply this together in the matrix form, we're not going to get 5 numbers. We're going to get 1 single number, because if I multiplied this and then down with the first column, if I changed this to a column vector, then it would multiply the corresponding entries, all right, but it would sum up together the results. Right? And if that sounds familiar to you, that is the dot product that we talked about in the last section. Now look at what happens if I do car time and put the prime at the end. This is the transpose operator. If I do that, it changes the car time vector into a vertical vector. So as we said in matrix, you need to go multiply across and down for every row in the matrix, across and down. So if I, say, well, okay, I need to do that. I need to multiply in the matrix way. Car speed times car time prime, because I think, okay, these are matrices, I need to do it this way. I'm just going to get 1 number. And then this isn't what I want. I didn't want 1 number. I want to know the distance traveled by each one of these cars. So why am I getting a number here? Basically, what we've calculated here is the dot product of these 2 vectors, which we've learned about in a previous section. When you multiply matrices, either you're going to get another matrix back, or if they're vectors, you're going to get the dot product back. So the trick is here, you need to know what type of multiplication you're trying to do. The traditional mathematical definition of vectors, you can only multiply vectors 2 ways, right? The traditional way. The first way is the dot product. The dot product returns a number. That's what we've calculated here. It's the same thing that we get if we type in dot car speed, comma, car time. And you actually notice here, I actually accidentally capitalized the D in dot. So MATLAB doesn't understand what that is. All of the commands in MATLAB are lowercase. So you see when I put the correct command in, we get 26.1. What we calculated here was really the dot product of these 2 vectors. So there's really only 2 ways to multiply vectors. The dot product gives you a number. That's what we did here. We talked about that in previous sections. And the cross product of 2 vectors gives you a new vector. In neither one of these guys is really what we're trying to do here. Right? Let me go ahead and clear the screen and I'll show you what we need to do. So let me type in car speed and car time. What we really want to do here is we don't want the dot product of these vectors and we don't want the cross product of these vectors. We want to multiply element by element the speed times the time speed times the time, speed times the time, speed times the time, and so on. We want to tell Matlab, don't treat these as real vectors in math or matrices. Treat them as lists of numbers and multiply element by element what's going on here. That's what we're trying to tell Matlab to do. So the way you do that is you say car distance equals car speed, and then what you do is you put a dot after car speed, and then you put a multiplication symbol, and then you put car time. When you notice, if we don't have this dot here, we got an error message. The dimensions weren't correct. When you put a dot in front of the operator here, the dot in front of the operator here is multiplication. When you put a dot in front of it, it tells Matlab, hey, if these are vectors, just do them element by element. Instead of trying to conform to the rules of mathematics, just do them element by element. So when we hit enter, we get a new vector, car distance, which contains the multiplication element by element. So the first car went 2 times 2.4, it went 4.8 meters. The last car only was allowed to go down the track for 1 second, so it only went down 2.7 meters. And the other guys are just a straight multiplication of the distance, of the speed times the time. So I can't tell you enough how common this is in Matlab when you'll have vectors, which are just a list of numbers, and you want to multiply them together in a way that in a non-traditional mathematical way. Traditionally, mathematically, you're either doing a dot product with vectors or cross product with vectors. In this case, we don't want that. We just want to treat these as a list of numbers and multiply the elements together. So you can have many, many occasions when you might want to do that. And so this is how you do it. This dot in front is what actually pulls it off. All right, what I'd like to do now is clear the screen and do one more quick example to show you when you would use this. So let's just, instead of going through a thought experiment with something practical, now that you know the purpose of this, let's just define something called vector1, and let's put, 5 space 4 space 7 space 1 space 2 space 3. We'll call it this. Vector 1 has 6 elements. Vector 2 also needs to have 6 elements, so we'll just call it 1, 2, 3, 4, 5, 6, like this. Vector 1 and vector 2 represent some data. If you want to dot vector 1 and vector 2, then you use the dot command or use the multiplication with the transpose. So if you wanted to actually dot these guys together, you just do vector 1, vector 2. Dot product returns a number. If you don't like using that notation, you could just multiply them. Vector 1 times vector 2, but you have to put a transpose there, otherwise the vector multiplication can't follow the rules of math, so you have to do it that way. So there's 2 different ways to arrive at the dot product. And the cross product we've talked about before as well. You just replace this word with cross and it'll cross the vectors out. But if you want to multiply these vectors together element by element, the way you do it is you say vector 1 dot times vector 2. The dot says do this element by element, multiply these vectors together, and then we get the answer. So 5 times 1 is 5, 4 times 2 is 8, and so on. Let me go ahead and clear the screen. Let's put vector 1 back up here and vector 2 back up here. If you'd like to divide vector 1 by vector 2 element by element, notice that division in terms of matrix math doesn't even make sense. There's really not a division operator where you divide one vector by another, so it doesn't even make sense mathematically. If you want to do these guys element by element, then the way you would do it is vector 1 dot divided by vector 2. The dot right before the operator tells Matlab, okay, do whatever the operator is, but do it element by element. So when we get this, 5 divided by 1 is 5, 4 divided by 2 is 2, and so on. So you get a straight element by element division. So that is about all I wanted to say in this section. Element by element operations in Matlab with vectors is very important. I tried to give at least one simple little practical example of when you might want to use it. The dot product and the cross product are the mathematical functions that we use when we multiply vectors in terms of pure math. Typically you have forces and things like that, and you have practical reasons why you'd want to dot and cross them together. These operations, when you're doing them element by element, is more when you're using MATLAB to store this as just a list of numbers that you might want to operate on with another list of numbers. And it has very practical things that you'll be using in your programming and also just in your everyday use of MATLAB there. So I hope to have illustrated this here. Make sure you understand anytime you see a dot like that in front of an operator, it means Do whatever it is you're asking it to do. Do it element by element.